Especially in early computing courses, students are commonly expected to work on programming assignments individually outside of a shared lab space. This practice can lead to social isolation and lower programming self-efficacy, factors known to reduce persistence within the discipline. Moreover, this practice runs counter to common programming practices in industry, where software engineers routinely collaborate on team programming projects. In order to decrease social isolation and build a sense of community in early computing courses, we propose to leverage current trends in social networking. OSBIDE represents a new breed of social programming environment that enables students in a class to participate in an online community rooted in shared programming activities and progress. OSBIDE promotes social awareness and collaboration by compiling students' programming activities, including their compilation attempts, compilation errors, runtime errors, and debugging events, into a shared activity stream. This stream, viewable by all, can be searched and commented on in a manner similar to that of popular social networking sites such as Facebook. Notice that, whereas other collaborative software development environments are designed to support teams as they work on a shared code solution, OSBIDE supports individual assignments in which each student implements his or her own solution to the same programming problem. This approach favors the approach taken in early computing courses, which typically emphasize individual work. Guided by social learning theory, OSBIDE is designed to support multiple levels of virtuous learner engagement. Learners begin on the periphery of a learning community by observing others' activities and progress. As learners become more engaged and experienced, they participate more centrally in the learning community by interacting with others through online question-asking and question-answering interactions. In order to design OSBIDE effectively, and in order to better understand its educational affordances, we are presently engaged in an empirical research program consisting of iterative mixed method studies. In these studies, key design questions include: what programming activities will be most useful to users? And how can programming activities be best presented in the activity stream so as to make them relevant and meaningful to users? Key research questions include: how will the environment impact retention, learning outcomes, and learning processes? How do students appropriate the environment? How do individual student differences affect students' use of the environment and the benefits that they reap from it? And what forms of student participation emerge, and how do they change over time? This project was begun in 2012 and recently received support from the National Science Foundation's Cyber Learning program. For additional information and project updates, please visit helplab.org.